Hey, Allen High School kiddos, welcome back to our discussion of acid and base chemistry. Now, I want to do, and I'm not going to belabor this point too much, I'll do a couple of examples. This is something you're supposed to know already, but let's refresh your memory on acid and base naming. The key to naming and writing formulas, and most of the time, you're going to have to go from formula to name. Far more often than name to formula. The key is understanding your anions. So if you don't know your polyatomic ions, now would be a really, really good time to rememorize those. You've got to know those polyatomics. Now, do you remember the phrase? A student of mine made this up years ago. I ate something icky. So ate turns to ick. And just leave the per on there. We don't bother with that. We don't drop our prefixes. Ate goes to ick. Just leave the per. So that's one rule, really, between those two. All night, I was nauseous. Ite goes with us. And again, it doesn't matter if the hypo is in front or not. Ite goes with us. Now, I took a ride, IDE. That's the only time that it's hydro in front. We add a word in front. Now, those are going to be single element anions with one exception. We have chloride and bromide, hydrochloric acid, hydrobromic acid, hydrofluoric acid, once we put the H pluses with them, okay? So HF, hydrofluoric acid, HBr, hydrobromic acid, HCl, hydrochloric acid. Now there is an example, Cn minus is, an exception, Cn minus is HCN. It is cyanide and it has two elements, but we follow the rules. It is hydrocyanic. The exception is it's a hydrocyanic when it's two elements as opposed to a single element anion. So let's take a look at these. Step one is to write the anion formula. Remember, the cation in each case is H plus, is your cation. So your anion is Br minus. Single element anions end in IDE, so that's bromide. Ide goes to hydro. It's the only time you add anything in front. Bromic acid. So if you see the word hydro in front, you know there's no oxygens in the acid. Okay, so that's a key clue. Okay, SO4, H plus is the cation, SO4 2 minus is the anion. That's the sulfate anion. 8 goes to ick. Okay, now you might want to go sulfic, right? But that doesn't even sound right. Sulfic acid, and always give it that last name, acid. Sulfic doesn't sound right. Sulfuric acid. Okay, we add the UR and the OR back in. Do you remember that? Okay. Anion name, whoops, I don't know why I was doing sodium there. Anion name is NO2, anion formula, NO2 minus. Nitrate is NO3 minus. One less oxygen must be nitrite. Ite goes to us. All night I was nauseous. So this is nitrous acid. Okay. So hopefully you're getting the idea. Let me do one more. Let me do this one. IO minus. Anion name. Well, the 8, you always want to reference back to the 8. The 8 is iodate. This is 2 less oxygens, so it's hypoiodite. Doesn't matter whether it's hypo or without the hypo, ite goes to us. So hypoiodus, we don't drop the prefix, acid. Okay? So hopefully that gives you a little bit of a refresher on writing formulas for acids. Now to go to the opposite way, let's look at the ending. We have us and no hydro in front. Us came from ite, so that must be phosphite. Okay, now always reference to your most common form. My most common form is phosphate, PO43 minus. Ite is one less oxygen. Now, to get the acid formula, remember H plus. Sorry, my mind went ahead of me and I just messed up there. Let me fix my mess up first. Okay? Keeping that hand and mouth and mind and all together. Man, it's tough at night. Okay. Remember, H plus is my cation for an acid, and I need as many H pluses as I need to neutralize those negatives. So if I have 3 negatives, I need 3 positives to provide charge balance. So that would be your acid formula. Perchloric, ic came from 8. So that must be we don't drop those, remember, perchlorate. So go to your most common form, chlorate ClO3 minus. Per means add another oxygen above, -1. My cation's H plus, I need 1 H plus to balance that negative, and that's HClO4. Let me change colors just so it's a little bit more visually distinct. Sulfurous. Us came from ite. That must be sulfite. Remember, we dropped that UR and OR. Just say it out kind of in your mind, and I think you'll hear that it doesn't sound right. Sulfate is SO4, 2 minus. Sulfite, therefore, must be one less oxygen, right? Ite is 1 less oxygen than 8. I need 2 H pluses to balance out those 2 negatives. So it'd be H2SO3. Okay. Let's jump down to, I want another color. I'm getting bored, kiddos. I don't know about you, but I like color. I don't know. Maybe that wasn't such a good idea. Mimio's not happy. I'm getting my little twirly rainbow that makes me nervous that it's going to shut down. Okay, so now we've got nitric acid. Let's do perbromic acid. We leave that. Ic. That's the same as perchloric. Let's go down one more. Hydroic. Remember, hydro's the one time we've added a prefix, and we do that for IDE. So I'd went to hydroic, sulfide. Sulfide is the single element anion, 2 negative. I need 2 positive hydrogens to charge balance the 2 negatives on the sulfur. Let's try acetic acid and we'll be done with it. Ic came from 8. So we have acetate. There's a variety of ways you will see acetate written. C2H3O2 negative, in which case you would write the H in front. Okay, notice that my H is in front. It's to distinguish between the H's that are bonded to carbon. So it's HC2H3O2. Now, another way to write that is CH3COOH. And that's because the actual structure, didn't give myself enough room, let me do it here. My actual structure of acetic acid is a carbon with 3 hydrogens. Those hydrogens are not acidic, they don't come off. Then a carbon with a double bonded oxygen and an O and an H. That's what that COOH means. And it's this H that's acidic. Okay, so a couple of ways you can write acetic acid, and I accept either of those, and you may see them both in your homework. So I wanted to show them both to you. Okay, bases are pretty straightforward. Strontium hydroxide, go ahead and write your cation and anion. Strontium's +2, hydroxide's -1. The lowest common multiple is 2, so I need 2 hydroxides for the 1 strontium, or 2 negatives to balance out that 2 positive. Potassium's +1, hydroxides -1, same charge, pop those puppies together and you have charge balance. To name them, this is like naming ionics. Magnesium, and then OH- is hydroxide. This last one, the metal is barium. Remember the old joke, what do you do with old chemists? Yeah, barium. It's pretty bad, huh? Okay, hydroxide. All right. So that's a quick review of naming. We're going to get into calculations in our next series of videos, and I think you'll like these. They've got a kind of a nice fun pattern that most of you like to work on. I think you'll enjoy that. So until then, as always, this is signing off.